Okay, picture this. You are sitting in the exam hall. You've got exactly 90 minutes to glory. This right here, this is your championship final. The clock is ticking down, the tension in the room is palpable, and you turn the page to a massive multi-part scenario question. The topic? Acting ethically versus unethically and its impact on a given situation. Now let's be real for a second. This is exactly where dreams are either made or completely broken in Cambridge computer science. Let me introduce you to two hypothetical students who are taking this exact paper right alongside you. We'll call them Alex and Sam. Now Alex looks at this massive ethics question and immediately starts panic writing. We're talking a massive brain dump, just overloading the page with raw computer science facts memorized from the textbook, but providing absolutely zero analytical depth to the actual scenario. And then, sitting right next to Alex, is Sam. Sam is rushing, Sam breezes through the reading time, completely misses the specific command word requirements of the prompt, and starts answering a question the examiner didn't even ask. When the results finally come out, both of their papers are just absolutely covered in red pen marks. And you might be wondering why? Because most students lose incredibly easy marks on these acting ethically versus unethically questions. They treat it like a casual general knowledge quiz instead of the rigorous analytical exercise it actually is. But listen, we are going to dive straight into the examiner's playbook today, so you absolutely will not be one of them. We are going to transform those red crosses into green check marks.
Welcome to This Explainer. Today, we're going to transform the official Cambridge Principal Examiner reports into your ultimate, foolproof game plan for exam victory. We're specifically focusing on the advanced AS and A-level computer science syllabus, that's code 9618, to dissect exactly what the examiners are desperately looking for, point by point. We are leaving nothing to chance here.
All right, let's look at our roadmap for today's session. 1. The examiner traps. 2. Core theoretical principles. 3. The procedural framework. And 4. Critical evaluation. We've got a lot of ground to cover, so let's dive right in.
Section 1. The examiner traps. We are starting straight from the source, the principal examiner reports. These are the exact, incredibly common pitfalls that catch thousands of candidates every single year. Oh, and before we continue, subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So the absolutely crucial point here is that examiners consistently report these three exact failures year after year. First up, confusing cause and effect. Now, this is exactly what happened to our student Sam. Sam might furiously write down that an unethical algorithm causes bad data. But think about it. In reality, biased training data is the cause, and the unethical algorithmic outcome is the effect. Examiners absolutely hate it when you mix these up. It shows a fundamental misunderstanding of systems. Second, forgetting to check boundary conditions and edge cases. In computer science, an ethical dilemma almost always occurs at the absolute boundaries. Think about it. What happens when an autonomous vehicle encounters an incredibly rare edge case it wasn't explicitly programmed for? You have to discuss these limits. You can't just talk about normal operation. And third, providing answers that are not specific to the given context. Now, this was Alex's fatal flaw. If the exam question asks about the ethical impact of a biometric database in a children's hospital, you literally cannot just list generic privacy concerns you memorized. You must talk about vulnerable patients, medical records, and specific healthcare vulnerabilities. Giving a generic, copy-pasted answer instead of a deeply contextual one will instantly, and I mean instantly, cap your grade.
Moving right along to Section 2, Core Theoretical Principles. Let's really look at how building a rock-solid conceptual architecture helps you completely bypass those traps we just discussed.
Okay, so a lot of students who successfully navigated earlier syllabuses, like your IGCSE or O-level codes 0417, 0478, 0983, 0984, or 2210, they sometimes unknowingly carry over some really bad habits into the advanced 9618 course. They try to rely entirely on rote memorization. But listen to me, at the AS and A-level standard, memorization is just not enough anymore. You need to intimately understand how the intricate moving parts of computer science interlock with human ethics. And what's really fascinating about this is that top-performing students, the ones getting the highest tier grades, they don't just memorize isolated, disconnected facts. The principal examiner report literally states, and I quote, that candidates who show connected conceptual understanding across the entire syllabus achieve significantly higher marks. What does that mean for you? It means if you are discussing the ethical impact of a new software system, you shouldn't just vaguely talk about ethics. You should deliberately connect it to data security protocols, or discuss how interpreting complex binary representations correctly is an absolute ethical obligation for software engineers to prevent catastrophic real-world system failures. It is all about proving to the examiner that you truly understand the big picture.
Now, I need you to pay close attention because examiners issue a massive flashing warning here. Candidates consistently confuse key terminology when they are writing out extended responses. Let's say you are going to talk about malware in an ethical scenario regarding a massive corporate data breach. You must explicitly define what malware actually is first before you start analyzing its impact. If you are discussing phishing as an unethical practice used by bad actors, define it clearly in your opening sentence. Establishing these precise textbook definitions right at the start of your paragraph creates a remarkably solid foundation for your argument. It immediately signals to the examiner, hey, I know my stuff, I am an expert. Making this a non-negotiable habit will instantly protect your score and prevent you from bleeding those incredibly easy foundational marks.
And this concept right here brilliantly illustrates that the entire assessment framework demands logical, evidence-based reasoning over just listing broad, disconnected concepts. Remember our friend Alex? Alex frantically wrote a whole page of random bullet points. That is superficial breadth. To fix this and actually score marks, you need analytical depth. And the absolute secret weapon here is the PEAL framework. That stands for Point, Evidence, Explanation, Link. The very best students structure their computer science extended answers using PEAL. You clearly make your point about the ethical impact. Then you provide specific evidence pulled directly from the scenario given in the exam question. Next, you provide a deep, technical explanation of why this happens using correct terminology. And finally, you link it all the way back to the overarching command word of the question. I cannot stress this enough. One deeply analyzed PEAL paragraph is worth infinitely more than 10 superficial, panicky bullet points.
Let's transition to Section 3. The procedural framework. But, hey, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGSC to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGSC and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into the technical methodology and see exactly how executing a rigorous process earns you those critical method marks.
When you are tackling these massive exam questions, you absolutely must follow this exact step-by-step workflow to ensure you capture every single available process mark. Step 1 is where you decode the command word. Is the examiner asking you to identify, describe, explain, or evaluate? Make no mistake, each of those words demands a totally different depth of response. Step 2, you carefully extract the relevant data from the scenario, and please, whatever you do, don't invent things that aren't in the text. Step 3, select your analytical framework, exactly like the PEAL structure we just discussed. Step 4, execute your answer using clear, logical notation, especially if you are tasked with designing a solution or tracing an algorithm. And finally, Step 5, present the whole thing using the correct, explicitly defined terminology. If you rigorously follow this workflow, you systematically engineer a high-scoring response every single time.
All right, let's make this an interactive workshop. Imagine we've got a 60-second timer counting down right now. Challenge 1, data scan. I want you to mentally scan the data interpretation steps we're outlining and extract the core trend. Just look at the relationship there. Got it? The fundamental trend is that every specific action requires a highly specific, evidence-based outcome. For example, when you interpret data in a complex ethics question, say, extracting performance metrics from a raw binary representation of a system log, your expected outcome must be an accurate calculation that definitively proves whether the system acted ethically or completely failed. When you identify an edge case, the expected outcome is that you successfully uncover the absolute boundary limits of that software. You must systematically test the reasonableness of your findings to draw a rock-solid, evidence-based conclusion. No guessing allowed.
Always keep in mind that your algorithmic thinking, your step-by-step decomposition of a problem, and your rigorous testing is exactly what the examiners are looking to reward here. Process literally equals method marks. You need to show you're working logically, clearly, and without skipping steps.
And finally, we arrive at Section 4, critical evaluation. This is the big league. This is where you separate yourself from the average candidates and secure those elusive, higher-order assessment marks.
The deconstruct, solve, evaluate framework you see here is your ultimate, high-powered problem-solving engine for literally any ethical or unethical impact scenario they can throw at you. First, you identify the given information. And again, you are strictly sticking to the provided context. Second, you break the massive ethical dilemma down into small, logical, technical steps. Third, you solve it systematically. Fourth, and honestly this is incredibly crucial, check your proposed solution for reasonableness. Would this actually work in the real world, or does it create a new ethical disaster? And fifth, make your justified recommendations. You cannot just write they should use better encryption. That gets you nowhere. You must justify exactly why a specific encryption protocol mitigates the ethical risk of a data leak in this exact specific scenario.
So the really crucial point when performing comparative analysis, which by the way frequently comes up when evaluating two different solutions to an ethical problem, is that you must explicitly identify both similarities and differences to draw a valid conclusion. A massive grade-killing trap is that students only ever talk about how two things are different. But to unlock full marks, you have to use comparative connectives. You want to write things like, similarly, both algorithm A and algorithm B prioritize data anonymization to protect user privacy. However, in stark contrast, algorithm B requires significantly higher processing power, which introduces a severe ethical concern regarding environmental energy consumption. See what we did there? You align the approaches to show similarity, and then you sharply contrast them, supporting every single claim with hard technical evidence.
To truly master this final section, you must learn to rigorously evaluate algorithmic quality against these 4 very specific criteria. Okay, it's time for challenge 2, find the flaw. I'm going to give you a hypothetical student sentence, and I want you to find why it's losing marks. Ready? The algorithm is bad because it is slow and might fail sometimes. Take a second. Did you spot the flaw? The sentence is bleeding marks because it has absolutely 0 analytical depth. Let's fix it. Challenge 3, speed writing. Instead of saying it is slow, you must assess the time complexity, perhaps stating it operates at big O of n squared, making it highly inefficient and ethically problematic for processing large, time-sensitive medical data sets. Instead of vaguely saying it takes up room, you assess the space complexity. Instead of it might fail sometimes, you explicitly identify the precise edge cases that trigger the failure. And finally, you determine the exact measurable effect on system performance. If you write your PL paragraph using these precise terms, you are guaranteeing your marks.
And just like that, we've reached the final system recap. To hit that 100% mark potential, you have to remember the 3 unbreakable rules of our success blueprint. Rule 1, command word decoding. Know exactly, precisely what the examiner is demanding from you. Rule 2, PL framework application. Structure your depth perfectly so every sentence earns its keep. And Rule 3, the time management matrix. Allocate your 90 minutes effectively so you don't end up rushing and panicking like Sam did. Listen. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
The very next time you sit down to analyze a system or write an exam paper, ask yourself a serious question. Are you just processing data, or are you actively shaping the ethical boundaries of tomorrow's technology? Because the true mark of an incredible computer scientist isn't just knowing the code, it's profoundly understanding the consequence. Keep analyzing, keep evaluating, and stick to the frameworks we talked about today. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.